All right, so we've seen a lot of gas laws so far, and they've all been used to describe a changing system. If you have one condition and you change it to something else, then you're going to use those components of the combined gas law and Avogadro's law. The other gas law that's very important that can be used to solve problems is called the ideal gas law. And in the ideal gas law, you're going to be given P, V, N, and T. So you're going to be given all of those things, and we can combine those all into one formula, and that is PV equals nRT. It kind of rhymes. PV equals nRT. All right. R is the universal gas constant, and it has some crazy units because remember, constants are mathematically derived to cancel units out. Okay, so 0.0821 liter times atmosphere over mole times Kelvin. Okay, that should be times. It's like it thinks I want to do something different. All right, liter atmosphere over mole K. If it's in millimeters of mercury, you can also do it in millimeters of mercury, but R is a different number. So we usually just use this one, okay? And because we use this one, we're going to have to make sure that our units are in liters, atmospheres, moles, and Kelvin. But we already know how to do that, so it's not going to be a problem. So remember, an ideal gas law, the PV equals nRT, is going to be used if it just describes a system. The combined gas laws, the P1V1 and P2V2, you got to have more than one of those. All right, so that's how you're going to know which one to use. All right, so an ideal gas problem would be how many moles of gas are contained. Okay, so moles of gas, and moles is N, okay. How many moles of gas are contained in a typical human breath that takes in 0.5 liters of air at 1 atmosphere pressure and 37 degrees C. All right, so it didn't change anything, did it? It just wants to know the third component. And we can solve for that with PV equals nRT because we always know what R is. 0.0821 liters times atmospheres over moles times Kelvin. So the first thing we have to do is we have to, and we're not going to choose, we're going to use the 0.0821. So we know that we're going to have to convert our temperature to Kelvin because it was given to us in Celsius, so we convert our temperature to 310 Kelvin. We've got our liters, atmospheres, moles, and K, and so since now that was the only thing we really had to change, and so now we can rearrange the equation. So we are going to have to divide both sides by RT, because that will cancel this RT and allow us to solve for N. So PV over RT. And then we plug and play 1 atmosphere, 0.5 liters, 0.0821 liter atmosphere over mole K, and 310 K. And when you put that into your calculator, you should get 0.020 moles. So the ideal gas law is just describing a situation as opposed to the combined gas law, which is describing a changing situation.